Hey guys, welcome to Unit 5, Lesson 6. We are doing limits at infinity today. So pause the video and try the warm-up. So the warm-up says you have a piecewise function and you want to find out these values, these limits. So limit as x approaches 0 of f of x. So again, oh, my pen. I don't know where my pen went. Hold on. It's right here. Okay, so it says x of 0. So I'm going to try for this one and this one. I'm going to try substitute in and find a value. So, and see if they're same. So limit as x approaches 0 from the left, right? So from the left, I'm going to try the first function, which would be x plus 5. So this would be 0 plus 5, which is 5. Now limit as x approaches 0 from the right, I'm going to try this function, which is 2. Limit of any number is just 2. So now look here, these two are not the same, so the limit does not exist. Right? The left limit is not equal to the right, so the limit does not exist. So let's try the next one. Limit as x approaches 3. So if it's x approaches 3 from the left, I'm going to use this equation, and for the right I'm going to use this one, right? So let's get started. Limit as x approaches 3 from the left of f of x, what do I get? Of 2 is equal to just 2. Limit as x approaches 3 from the right. From the right, I have x squared minus 7. That's my function. So I'm going to substitute 3 in for x squared minus 7. 9 minus 7 is 2. So these two are same. So the limit exists, and that's equal to 2. And that's your answer. So limits at infinity. A limit at infinity is the value a function is approaching as x gets infinitely large or infinitely small. In order to find the limits of a function as x approaches positive or negative infinity, we need to look at the horizontal asymptotes. I hope you all did follow along what we were talking about, the horizontal asymptotes, right? So now let's fill in this. If L is a horizontal asymptote of f of x, then limit x approaches positive or negative infinity, f of x is equal to your horizontal asymptote, whatever that would be. Okay, so let's get started with example 1. It says limit as x approaches infinity of this polynomial function. So think about it. As x is getting larger and larger, what would your f of x do, or your y value be? It will get large too. So this is just positive infinity. The next one is limit as x approaches infinity 2 plus 1 over x. So I can rewrite it twice, or you can just do it without writing it twice. That's okay, but I like to rewrite it twice. And now limit of any number is just the number. So now think about it here. Your x is getting very, very large. What will this be? What would your y approach? It would approach 0. So it's just 2, right? The next one, as x is getting closer to negative infinity, what would your y be? This is, again, isn't it a cubic function, right? Which looks something like this. That's what it looks like. So x is getting very close to infinity, so your y is also going to be approaching negative infinity. So very straightforward, just looking at the end behavior. We're talking about the end behavior, or what is happening to my y's when x is getting, depending on the question, either very, very large or very, very small. Let's look at the next page. It says evaluate each of the following using your calculators. So you need to take out your calculators and given the function this, and then find the following. So f of 10, so I'm going to substitute 10 cubed plus 10 square plus 1 over 2 times 10 cubed. Now look at this. What do I get? I'm just going to actually write it out so we can see. We're just doing a little discovery here so that you understand what we're getting to. 2 times 1000, which would be what? 1101 over 2000. So I did all that math. I hope you all have that answer. What I'm trying to get to is, what do you notice about the values of f of x as x is increasing? So what value is it approaching? If you put those in the calculator, don't you get a half, right? It's approaching half, or I will say, let me write closer to a half. It's closer to 1/2, right? How can you see this in the function itself? It is basically your what? Your horizontal asymptote. So if you were to look at the graph, you'll see as your x is getting very, very large, you are approaching, y is approaching more and more closer to, for this question, to 1/2, which happens to be your horizontal asymptote. Okay, so let's do example 2. Let's get started with this. Limit as x approaches negative infinity. So as x is approaching negative or positive infinity, your y will be approaching your horizontal asymptote. And how do we determine horizontal asymptote? I did explain in the past. So if your degree of the numerator and the denominator is same, it's just the coefficients. So it's x squared over 3x squared. That's the highest degree. So it's going to be 1 over 3. This one, I can choose to write it separately, or if you can determine it alone without writing it separately, it's not bad. Minus limit as x approaches negative infinity, 5x over x squared plus 1, right? Limit of any number is just 7 plus, if you don't remember that the degree of the numerator is less than the degree of the denominator, so what will happen? Let's do the method. If you put a placeholder for 0x squared, now what's 0 divided by 1? It is just 0, so it's going to be 7. I would say remember it, but I'm just giving you a tool to know in case you forget or you're confused with your horizontal asymptotes. Again, look at your coefficients or the highest degree. It's x to the third. Put a placeholder here, so it'll be 0x cubed. So what's 1 divided by 0? So it's no horizontal asymptote, so it's going to be approaching infinity. So try the problem set. Good luck.